Assalamu alaikum everyone. My name is Tahera Tabassum. Today we are going to be looking at the experiment for Hooke's law. So the objective of the experiment is to show the Hooke's law of spring and determine the spring constant, and to measure the stress length produced by different loads added to the spring. So what is the Hooke's law? Hooke's law states that the force needed to extend or compress a spring is directly proportional to the displacement from its equilibrium position. Mathematically, it's expressed as F equals to K times X, where F is the force applied to the spring and K is the spring constant, that measure of the stiffness of the spring, and X is the displacement, means the distance the spring is stretched or compressed from its natural length or original length. Let me tell you that elastic objects such as a spring can store elastic potential energy when they are stretched. For example, this happens when a catapult is stretched back. When an elastic object such as spring is stretched, the increased length is called an extension. The extension of truly elastic object, again, such as a spring, is directly proportional to the force applied, provided the limit of proportionality is not exceeded, meaning the object being stretched doesn't become permanently deformed, such as when a spring doesn't return to its original position after the load is removed. This proportionality is called Hooke's law, and the force is equal to the spring constant times the extension. The spring constant is measured in newtons per meter and is different for different objects and materials. You work it out by carrying out an experiment with an elastic object and adding a load or force to it. You then measure the extension of the object and sub the numbers into the formula to get the spring constant. The greater the value of K, the stiffer the spring. So today I will be demonstrating this experiment and I will show how this relationship works in practice, highlighting the connection between force and the spring constant and the displacement. So to do this experiment, I'm using Hooke's law apparatus and some weight bars. Each of these weight bars contains 50 grams. And we should take careful measurements of the length and extension of spring as we add different amounts of force to cause it to stretch. And to take careful measurements of length and extension, we need a ruler, and the zero mark of the ruler should be placed at the bottom of the spring. But as you can see, at my apparatus, this ruler is already attached and it is a little bit upper from the bottom of the spring. So I will take 4 centimeters as the zero, because the bottom of the spring is at 4 centimeters according to the ruler that is attached to my apparatus. Now I am going to hang these weight bars to the spring, and each of these weight bars contains the mass of 50 grams, and I will combine 2 weight bars together to make it 100 grams, because for this experiment I won't be recording the mass in grams, but I will be recording it as a force in newtons. And for this we need to convert it according to the equation weight equals to mass times g. And the mass, if the mass is 100 grams, it means it is 0.1 kilogram. And for the sake of this experiment, I will take g as 10. So each of this weight of 100 grams will be containing 1 newton. So it means there are 5 newtons of force that I will be hanging to the spring now. The extension, being a distance, is going to be measured in meters. So I have to make sure that I will convert centimeters into meters before recording the information to the table that I will draw. So now I'm going to add the first weight of 1 newton. After adding the 1 newton, we are getting the length of 3 millimeters. From adding a force of 1 newton, we got 0.03 meters extension. The first newton stretched the spring just a little. Now I'm adding the second Newton, which stretched the spring much more than before, and we got the extension of 2 centimeters because I started to measure it from 4. So according to this, we got the extension of 2 centimeters. Since we are recording the extension in meters, so we are getting 0.02 meters after adding 2 newtons of force. Now I am adding the third newton of force to the spring. It stretched the spring much more, and we got the extension of 9 centimeters. So after adding 3 newtons, we got the extension of 0.09 meters. Now I will be adding the 4th newton of force to the spring. So after adding 4 newton of force to the spring, we got the extension of 16 centimeters. After adding 4 newtons of force, we got 0.16 meter of extension. Now I'm adding the last one, the 5th newton of force to the spring. So after adding the 5th newton of force, we got the final extension of 23.3 centimeters. So after adding the 5 newton of force to the spring, we got the final extension of 0.233 meters. The next stage of this experiment is just to manipulate the data to produce a graph from which we can show the relationship between the force and the extension. So drawing a graph of this data, now usually we will expect to draw the dependent variable on the y-axis, but now this time around, for the purpose of our analysis from these results, we are going to flip and we are going to put the force, the independent variable, onto the y-axis and the extension on the x-axis. So I have plotted the graph by putting the values of force on y-axis and the values of extension on x-axis, and after that I have drawn a triangle by choosing 2 points. I have drawn a right angle triangle to find the gradient of the graph, and after that I found the constant of the spring. So here is the end of the experiment. Thank you for watching.